Hi, I'm Steve Bjork, and I'm going to show you how to build your first LambdaSharp module. It's very simple. We just need to look at a few commands. Lash new module, which creates a new module YAML file. Lash new function, which creates a C# project and adds its definition to the YAML module file. And lash new resource, which does the same but for resources. Then we'll deploy it and take a look at it in the AWS console. So let's get started. Back here I already have Visual Studio Code open. It's in a folder with a single file that ignores the bin and object files, which are byproducts of the compilation process. And now let's create a new module. Now when you create a new module, it requires a name, and the name is made out of two parts: the owner name and the proper module name. Now for the owner name, I'm going to use LambdaSharp. You should use your organization's name, your last name, your avatar's name, whichever, and then the name of the module that you want to create. And this now initializes a module YAML file. And at the top of it, you can see the name of the module. There's also a default version number, a placeholder for a module description, and then a first item, which is a variable in this case, in the items section. Next, we want to add a function. So we say lash new function. And it's similarly to creating a new module. It will query us for a name. Now I like to call my resources, give it a suffix that is identifies what type of resource it is. So I would call this my function. And similar would be my topic, my bucket. I found it to be easier later on when I look at CloudFormation description to know what I'm looking at without having to look at the actual type. Now, this created a project in our folder and also added this definition to our YAML file. Now let's take a look at the project folder. It's a CS_proj file with the dependencies that it needs, including the LambdaSharp assembly, and also a function file. And this is a very vanilla function, request response pattern definition. It derives from a Lambda function generic function, a base class, taking two generic parameters, one for the request deserialization and one for the response serialization. These are defined up here in the file, so you just have to fill in the details, and it's just like any other JSON object definition. And then down here we add the business logic. So this is a fully functional example. It doesn't do anything, but it's ready to be compiled and deployed. Next, let's add a resource. And again, it's a very similar process. We just say lash new resource. We'll ask us for a name. We'll call it my topic because I'd like to add an SNS topic for notifications. Now, similar to before, the definition will be added to our module YAML file. But in addition, we also have this properties section at the bottom, which shows you all the properties that you can set in this definition, which is based on CloudFormation. The name of the type is from CloudFormation, and all the properties are from CloudFormation. Indeed, there's actually a link also to the CloudFormation documentation for these topic objects or resources. Okay, in our case, we don't need it, so let's just comment it out. And we are ready to go. So let's go back to the command line, and we just say lash deploy. And this will automatically trigger the build and publish commands, because we are in a folder where there's a module YAML file. Now, the build part uses the Amazon Lambda Tools.NET tool, so that we always are building using Amazon's recommended approach. We do some post-processing with the LambdaSharp tool in order to checksum the assemblies and the produce artifacts to allow us to detect more easily if no changes occurred. .NET Core has deterministic build, which means that if you give it the exact same source code and the exact same dependencies, you will end up with effectively something that is binary identical to what you had built before. And that's really great because it allows us to identify when no additional work needs to happen, or maybe some functions, the code didn't change. So when you do an update to your CloudFormation stack, it will only update the functions where a change was required. Okay, now let's go over to CloudFormation in our AWS console. And if I go here, you will see the stack has been created. This is LambdaSharp, my first module. and all the resources are now present, all have been created. So this is a very similar output to what we saw on the command line just moments ago. Now let's go back, and just for as an example, let's add a parameter. So I'm going to remove the variable since we don't need it, and I'm going to add a parameter which allows us to configure this module. Let's just call it my topic title. It's a string, so don't have to give it a type definition. I will give it a description just because that is a little bit more user-friendly. This is the title of the SNS topic. And down here we can see how the title is being set. Now, let's say I didn't have this description in place. I went off memory and I call it display title. And I say I want to give it the value of my topic title. And I'm doing this to show you how the LambdaSharp compiler will detect these kinds of errors when you reference a property that doesn't exist or an attribute that's not defined. It will immediately fail compilation long before you try to upload it and deploy it, and CloudFormation detects it because it has a built-in definition of all the available types. So let's now fix our mistake here, put in the right name. Let's go back and deploy again. Now we added a parameter this time, and when we deploy it in interactive mode, which is the default mode, we will detect during the deployment process after compilation has occurred, and in this case we will see that it only uploads a new module template but no new function code, because that hasn't changed. And you can see at the bottom how it asks us for my topic title, and so now we can enter this is my title. And so this parameter is being automatically supplied. Now you could also supply parameters from the command line directly, which is what you would do in a CI/CD kind of environment. You can also tell it that to treat any prompts as errors, which you should definitely do in a CI/CD environment. However, for enabling quick development from the command line and just getting things up and deployed, this makes it really, really easy. And going back to CloudFormation, now that we have a parameter, we can go into our module here and we can say we want to update it. So we can reconfigure it without having to go back to the command line and redeploy it. We can just give it a new title here. This is another title. And since the dependencies between resources and parameters have been captured inside our template, CloudFormation will apply this change and update any resources that need to be updated because of it. So it's very, very nice. There's some additional sections here for parameters which have been generated by the compiler itself. Those, for now, we will just ignore. We'll have to acknowledge the other changes. We just go through. So scroll down continuously. Yes, I understand. This has IAM resources. We say update stack. And my parameter change is being applied. My SNS topic is being updated with what title it has. So a complete workflow both on the command line and in the AWS console that is set up for you to build your modules. And that's what I wanted to cover. So check out LambdaSharp.net for the latest news and updates to our documentation and tools, at LambdaSharp on Twitter to get in touch with us. And then, of course, check out the source code on GitHub. Hope you enjoyed it. Thanks.